All right. We are working on our definition for similarity. And we're going to mostly talk through how to kind of use and apply that definition today. And we talked about it last week, so most of what we're going to talk about today should be familiar to you. Two figures or polygons are similar if the corresponding angles are congruent and the corresponding sides are proportional. So we talked about this last week, how if we're changing the size of my shape, then I want them to all scale up by the same amount. And to preserve the shape, I want all the angles to stay the same. So that's my definition for similarity. The sides all scale up or down by the same amount, and then all the angles end up staying the same. So another thing for perspective of the terminology and the notation. Hopefully you know this is equals. This is what an equal sign looks like. For congruent, how does congruent look in comparison to this? Equal sign and then what? A little squiggle at the top. Like that. That means congruent. Now when we do similar, only the squiggle. Squiggle only. And so if you see that symbol with only the squiggle, then that means that the shapes are similar. And we can make what are called similarity statements, which are the same as congruent statements. It's showing, first off, there's our symbol for similarity. It's showing which sides and angles match up with what. So those are my symbols and definitions. So what we're basically going to do with this first example is we're going to use those symbols and definitions in order to show that these two shapes are similar. We're going to match up all the sides, we're going to match up all the angles, and we're going to use that to say that our shapes are similar. All right, let's start by matching up our angles. And we're going to match up our angles by where the matching tick marks are. So I'll start with the ones with one tick mark. One tick mark is going to be angle F. Angle F has one tick mark on it. And we're going to match that up with the angle in the other shape that has one tick mark on it, which is angle Z. So we have angle F congruent to angle Z. Then we're going to match up our two tick marks. We have angle H congruent, matching up with our two tick marks in the other diagram. That's going to be angle X. So now we've matched up 1 tick mark, we matched up 2 tick marks, now we'll match up 3 tick marks. Angle G has 3 tick marks, and it matches up with, which one has 3 tick marks in the other diagram? Y. Which leaves angle J with angle W. Now these pieces, J and W, had this little box at the top of it instead of tick marks. What does that mean? They're right angles, 90 degrees. All right. We covered our angles. They're all the same. Now we're going to cover our sides and make sure that we have that scale factor, that same amount that we're scaling up all the sides by. So let's check for that. We're going to check up our matching sides. And we're going to do that by making sure for our matching sides the way that I'm going to do that is we're going to check for a ratio in the fraction. So we're going to have a fraction that we simplify. In that fraction, I'm going to put the bigger shape on top every time. You don't have to do it that way. That's just the way that I'm going to organize it. Bigger shape on top. And then I'm going to start, when I match up these pieces, I'm going to start with the shortest side that I have. And then I'm going to do the next shortest side all the way up to the longest side. So I'm going to go from shortest to longest, biggest side on top, or bigger shape on top. W to X is 15. J to H is 12. So 15 over 12, we're going to reduce that fraction by saying both of these numbers are divisible by 3. So 15 divided by 3 is 5. 12 divided by 3 is 4. So we get 5 over 4. 5 over 4 now becomes my target. Because remember I said that all of our sides should reduce to the same thing. So now I want them all to reduce to 5 over 4. If any of them don't reduce to 5 over 4, then something's wrong. Because that would mean that the shapes aren't similar. So let's check the rest of the sides. We've done 15. The shortest side in the diagram after that is 20. So that's Z to W. And we're going to compare it to, we've used 12. The shortest side after that is 16. So that's J to F. These ones are both divisible by 4. 20 divided by 4 is 5. 16 divided by 4 is 4. So far, so good. We got the 5 over 4 that we were looking for. That was this pair of sides. We used 15. We've used 20. What's the shortest side that's left? 25. We're going to compare it to, we've used 12, we've used 16. Shortest side that's left? 20. So we have Z to Y. We're going to compare it to F to G. And if I'm simplifying that fraction, both of those numbers are divisible by 5. So we're going to take 25 divided by 5. That's going to be 5. 20 divided by 5. That's going to be 4. And wow, look at that, 5/4 again. We got that same ratio. We got one more to go. If it's 5/4, we're in great shape. If it's not, then we have a problem. We've gotten up to our biggest side in each shape, larger shape on top. That means XY on top and HG on the bottom. 30/24. Now the numbers are getting bigger, so the number that we're dividing by is getting bigger. These are both divisible by 6. Is our largest number we can divide both these numbers by. 30 divided by 6 is 5. 24 divided by 6 is 4. And yes, we have 5/4 again. That means that all of our sides are matching up. So that means that I get to write, the notes are calling this a proportionality statement. Your homework is going to call this an extended proportion. What I'm about to write. It's called extended because it is one big string of equal signs. And all that it's going to say is that these fractions that I just found, all 4 of these fractions, are all the same. That's all that we're saying here. So I'm going to write out all of my fractions that I just found. And the statement that we're making about these fractions is that they're all the same. So Wx over Jh equals Zw over Jf equals Zy over Fg equals Xy over Hg. And that's just saying that we just found the 4 fractions, we simplified them, and they all reduced to the same amount. In this case, it's 5/4. So since those all reduced to the same thing, and since our angles matched up the way they're supposed to, that means they're similar. And so we're going to write a similarity statement. F, G, H, J. That's my first shape. Is similar to, here's my squiggle. And now we're going to match up our pieces. So we're going to take F, first letter. It matched up with Z. So it's going to be so Z is going to be the first letter on the other shape. Then we have G, second letter. G up here matched up with Y. So Y goes there. Third letter is H. So H is going to match up with X. And then we have J. That leaves J to match up with W. So it's the same idea as the congruence statements. All the sides and angles need to match up there. So that is my similarity statement. And then my scale factor. Scale factor is whatever number I can multiply all those by. And it will not surprise you to learn that the scale factor we're going to use is 5/4. It's the number that all of our sides, all those fractions, ended up simplifying to. Questions on that problem? So all of that is a long way of saying our definition. Here's the angles all matching up and being the same. Here's the sides all reducing to the same amount. And this number is called a scale factor, so let's write that down as a definition. Sure, it'd already be in your notes when we talked about dilations, but we'll write it down again anyways. So same idea, we're using K to abbreviate our scale factor. That's the main thing I want to point out. So whenever you see K, we're using it to stand for scale factor. All right. Let's do some more examples. Now we're going to use the fact that our shapes are similar to figure out a side that we don't know yet. That's what we're working on here. So in the diagram, triangle DEF is similar to triangle MNP. And we're going to solve for x. So first off, I'm going to find my scale factor. There are a few different ways you can do this problem. What I'm going to show is, I think, the way to keep it the most consistent for every problem and to make the numbers as small to work with as possible. That's why we're starting by finding the scale factor. Because what the scale factor is going to do is it's going to reduce our fractions, reduce our numbers. So to get the scale factor, we're going to find two sides that are matching. Because the way I did the last one, I'm going to start with my shortest side. Shortest side here with the shortest side here. That's going to be 12 over 9. Bigger shape on top. And so 12 over 9, I reduce those. Those are both divisible by, what can I divide both of these by? 3. So 12 divided by 3 is 4. 9 divided by 3 is 3. So 4/3 is my scale factor. So I'm going to take that scale factor, that 4/3, and make it equal to the part that I actually want to solve for. Well, let's see. I want to solve for this side right here, x. And that x is going to be the length from E to F. And let's see, since it's the smaller shape, I'm going to put it on the bottom. Or I put the larger shape on the top. So since it's on the smaller shape, I'm going to put x on the bottom to make it matching with my smaller shape. And so that means if I want to know what goes on the top, well, I can just look at my similarity statement if I'm not sure. E to F, last two letters, should match up with last two letters, N to P. So 20 is the number that goes on top. So now we're going to solve this equation. I do not use the phrase cross multiply. You may hear it in some of your other classes to solve an equation like this. I'm not going to use it. What I'm going to use is I'm going to say something more like, ugh, I don't like fractions, let's get rid of them. That's more of what you're going to hear me say to solve an equation like this. So let's get rid of the fractions. If I want to get rid of this fraction, 4 over 3, that's 4 divided by 3. Fraction is just division. So we undo division by multiplying. So if I want to get rid of this 3 on the bottom, I'm going to multiply both sides of the equation by 3. And that'll get rid of the fraction on the left side. But that doesn't get rid of the fraction on the right side. In order to do that, I need to multiply, because I have an x on the bottom here. So to get those to cancel and get rid of the fraction, I need to multiply by x so that the fraction cancels. And if I do it on the right, got to do it on the left. So we're going to multiply by x on both sides. And this is going to get rid of those icky gross fractions that I don't like. And we'll make the equation much easier. 3's cancel here. So I have 4 times x. Equals, over here, x's cancel. No more fractions. Hooray. 20 times 3 is 60. And now we know how to solve this. This is 4 times x, so we're going to divide to undo it. So the general thing that you're going to see in these problems is we have this fraction that we want to get rid of, so we're going to multiply by whatever thing is on the bottom. That's what we're going to do. Questions on this one? All right, I'm going to give you a few seconds head start on the next one to see if you can get, start by seeing if you can get the scale factor. To get the scale factor, you're going to need to match up the two sides that we know and don't have the x attached to them. So we're going to match up the sides that we actually want to solve for. I'm going to put the bigger shape on top. These are both divisible by 4. I'm going to still make this a fraction because the other side's going to be a fraction. Equals, and now we're going to set it up with the other side that we need to know. Let's see. That means that side will help us solve for x. So what we're going to compare it to is b to c. And we're going to match up b to c, last two letters, with last two letters e to f. Which one goes on top? The 18 or the x minus 1? It's the 18 because we're putting the bigger shape on top. So we want to keep consistent. (18 over x minus 1 is what goes on the bottom. Once again, fractions, I don't like those. Let's get them out of there. Kick them out. All right, this is dividing by 1, so I just multiply by 1 on both sides. On the right side, I've got an x minus 1 on the bottom. So I want to get rid of this x minus 1. I want it to get out of the bottom. So to undo that dividing by x minus 1, I'm going to multiply by x minus 1 on both sides. So we're multiplying on both sides in order to get rid of the fraction. Over here, 1's cancel. And we have 3 times this x minus 1. That's what we're left with. Over here, x minus 1's go away. Now there's no more fractions. Great news. 18 times 1. So notice, if you prefer, that this gives the same result as if we did this. Right? But that's more of a trick to memorize and less of it looks more to me like a trick that you memorize and less like I'm solving an equation. This looks more like I'm solving an equation, and I'm solving it by getting rid of the fractions, undoing division with multiplication. Let's distribute. 3 times x. 3 times 1 is 3. Equals 18 times 1 is 18. And now we can solve. Let's add 3 to both sides. And 18 and 3 is 21. So now we can divide, and we can get x to be 7. One last thing here. We can double check our answer as always by plugging in for x. If x is 7, then that means that this length ends up being 7 minus 1 equals 6. And we can make sure that our scale factor of 3 over 1 still works out. We have 18 over 6. Hey, that's 3 over 1. Over here, 7 and 1 is 8 times 3 is 24 over 8. Still 3 over 1. And so that all checks out to